So in this video, I'm going to talk about the proof of Pythagorean theorem. And we know that Pythagorean theorem is one of the most important theorem in the world, most of the useful. And I'm going to prove it here. And at first, let's review the Pythagorean theorem. And we know the formula for it that a squared plus b squared should be equal to c squared, where c is the legs of hypotenuse, which is the largest, which is the biggest, longest side in the triangle. And we can only apply this theorem when it is only right triangle. And for c, it is always opposite side of the right angle, which is in this case C, and A and B are the legs, and the order of A and B is not mattered. So let's prove it. And here's our right triangle, and this is the form that we prove right over here. This is the general way of we prove it. The thing that I did in here is that it is our right triangle like this right over here, and we kept rotating. We kept rotating around, and we made a big rectangle. Um we made a big square, and we can use Pythagorean theorem. We can prove it by this thing right over here. The thing that we did is just rotated. We just rotated, and so here right over here. So I'll write down big square, big square right over here. That area is equal to 4 triangles. So 4 triangles plus small square. So small square. We can prove it with this thing right over here. What about what is the area of the big square right over here? Well, it is the length square, which means a plus b will gonna be length a plus b, so a plus b, and a plus b times a plus b, which means a plus b squared. That should be equal to small square. Let's just do this four triangles. Well, 4 triangles, the area of triangle is that the height times base times 1 over 2, and there are 4 triangles, so 4 times, what is it, 8 times b, it's going to be 8 times b, so 8 times b, I'll just write, so 8 times b times 1 over 2, and all of that plus the small square, which is c times c, which we're going to be c squared. And we can simplify this left term right over here, that I'll write down a plus b squared is equal to a plus b times a plus b, which means if we use the history property, we're going to be a squared plus 2ab times b squared. It is the property of the binomials. So we can say that this thing right over here, it is a squared plus 2ab plus b squared, and that should be equal to, well, 2, let's see, 2 and then 4 we're going to cancel out into 2, so that should be equal to 2 times ab plus c squared, and we're not quite yet with this original formula for Pythagorean theorem, which is a squared plus b squared should be equal to c squared. But if you look at this equation right over here, we can subtract 2ab to the both sides because they both contain 2ab. And then the 2ab we're going to cancel out, and then finally we'll get a squared in the left term plus b squared, a squared plus b squared should be equal to c squared, We came back with our original Pythagorean theorem. So this was the proof of Pythagorean theorem in a general way. So we finally got the answer that a squared plus b squared should be equal to c squared.